All right, in this video, I'm going to do the warm-up to lesson number 1. All of these problems say to solve for x, and each one of them is going to be solved a little bit differently. So problem number 1, I actually have 2 different ways I can solve this. So I'm going to show you how to solve it with factoring, and then separately, I'm going to show you how you can solve it with a square root. To solve it with factoring, you're going to subtract 25 from both sides, so you can make the right side equal to 0. You've got the factors then of x minus 5 and x plus 5. And then once you get it factored, set each factor equal to 0 and solve. So you would get x equals 5 and x equals negative 5. So there's my 2 answers. Now that's one way to solve it. You can also just look at it and realize that x squared is all by itself on the left side, and the opposite of squaring something is to take a square root. Now, the only thing you got to be careful about with this is when you put a square root into the problem, you must include a plus or minus, and the square root of 25 is just 5. So this is the exact same answer as this. All right, x equals 5, well, that would be the positive 5. X equals negative 5, well, there's the minus 5 or negative 5. So 2 different ways to solve it. It's not going to matter which way you solve it unless the directions say something specific. But with these directions, just said solve. So I did. Problem number 2, I'm going to solve for x. There's actually a couple ways you could solve this one as well. You could distribute here and then get x by itself. I'm actually going to go ahead and just divide both sides by 2 first. So this expression, then 3x plus 5 would be left over. 16 divided by 2 is 8. I'm going to subtract 5 from both sides. So 3x equals 8 minus 5 is 3. Divide both sides by 3. X is equal to 1. And if you did distribute, you should still get the same exact answer I just got. So sometimes there's multiple pathways to solve a problem. It just depends on what pathway you see to get through the problem. Problem number 3 is a little different. You are solving for x, however, you have a y in this problem. And we don't know what y is equal to. So we can't get rid of it, but we can remove it to the other side of the problem. So I'm going to isolate this 4x term. So I'm going to subtract, I'm also going to grab a pen apparently. All right, I'm going to subtract 12y. I'm going to add 28. I'm going to subtract 12y. I'm going to add 28. Okay, so those are gone. I have 4x equals, now 0 minus 12y is just going to be negative 12y. And then the plus 28 is going to tag along, so plus 28. Now, x is not completely solved yet because x is not by itself. So what's attached to x is a 4, and it's being multiplied, so 4 times x. So the opposite operation to multiplication is to divide. But if I divide, I need to divide everything by that 4. So let's see. Negative 12 divided by 4 would be negative 3y. And then 28 divided by 4 would be plus 7. So that's solving for x. Now, I don't know what x is equal to as like a single number. I can't look at it like problem number 2 and say, oh, well, x equals 1. I don't have that option for number 3. It's okay to solve an equation like this and just know that a variable, in this case, x is equal to an expression. That is totally okay. I'm going to go ahead and close the video here for just this warm-up, and then the next video we'll get into the vertical line test, functions, being invertible, and all that fun stuff. Let me know if you have any questions or concerns on